Hey guys, so today we're going to continue our unit on applying equations and inequalities. But before we can start about applying equations, there's another type of an equation that we need to learn how to solve. And this type of equation is going to have variables on both sides. Now, previously, we have learned how to solve an equation that looks like this. X minus 7 equals 3. Okay, we would know to just add 7 to both sides and we get x equals 10. And then we learned how to solve two-step equations. So something like this, 2x minus 7 is equal to 3. Okay, so we would know that first we would have to add 7 and then we would divide by 2. And so we would know how to solve that, right? Well, we're going to be looking at a new type of an equation, something that looks like this. I'm just going to show you with doing an example, example 1. Something like 7x is equal to 16 plus 5x, okay? So the question is, what is the difference between this equation, for example 1, and the two equations that we've already studied, okay? And here's the difference. There is a variable on both sides of this equation. Okay, there's an x here and there's an x here. Okay, because of that, we cannot solve this how we would solve a one-step equation where we just do the inverse operation. And we can't solve it like we do a two-step equation where we solve it using the inverse operation, but we have to reverse PEMDAS and do two different steps. Okay, so in order to solve this equation where you have a variable on both sides, we have two options. Okay, we have two options. Okay, the first one is you're going to eliminate the variable from the side that has the smaller coefficient. Okay, and when I say eliminate, that means by using inverse operations. Okay, but with the entire variable, in the entire term. Okay, so let me clarify that. You're going to use inverse operations on the entire term, right? And remember, a term includes the number in front of the variable and the variable itself. So we'll see that in action in just a minute. But option 2, let's talk about option 2 first. Option 2, what we would do is you would eliminate the variable on the right. Always just eliminate the variable on the right. Okay, using the same process. So you're going to use the inverse operation on the entire term. So on the right, using the same process. All right, so let's see this in action. All right, so let's go back to our example. 7x is equal to 16 plus 5x. Okay, if I choose option 1, which is eliminate the variable from the side that has a smaller coefficient, this is 7x and this is 5x. So the coefficients are the numbers in front of the variable. So 7 and 5 are my coefficients. 5 is the smaller coefficient, which means I would eliminate the 5x if I was doing option 1. If I were to do option 2, I would eliminate the variable on the right side, which also happens to do 5x. So for this problem, option 1 and option 2 are actually the same either way. All right, so we need to eliminate this 5x. And remember I said in order to eliminate it, we're going to use inverse operations, but we're going to do it on the entire term. Before, we were trying to keep the variable by itself. So we were doing the inverse operation just on the constant number. Now we're doing it on the entire term. So in order to get rid of a plus 5x, I'm going to subtract 5x. Okay, I'm going to subtract 5x. Think about it as subtracting apples. In order to get rid of 5 apples, I'm going to subtract 5 apples. But remember, it's an equation that has to stay balanced. Remember, so we're going to do it on the other side as well. So 7x minus 5x is 2x. And then 16 plus 5x minus 5x, well, 5x minus 5x is just 0, leaving us just 16. Now I have a one-step equation, which means in order to solve for x, I just have to get rid of the times 2, so I'm going to divide by 2, which means x will be equal to 8. Awesome. All right, let's look at our next example. Example 2. And this says 8x plus 5 is equal to x. So the coefficient for the variable on the left side is 8. The coefficient for the variable on the right is x. So in order to solve this, there's two ways we're going to choose. We can choose option 1 or option 2. Option 1 says we're going to eliminate the 1x. Option 2 says we're also going to eliminate the 1x. So it doesn't really matter which option you choose here. So let's go ahead and get rid of this 1x. This is a positive x. So to undo it, we're going to subtract x from both sides, leaving us 7x plus 5. And then x minus x, there's nothing left, 0. Okay, so we're going to go ahead and leave a 0 there to show that there's nothing over there. There's not a constant, there's not a variable, it's just 0. Okay, now we have a two-step equation, which means that we're going to take care of the addition and subtraction first. So we're going to subtract 5 from both sides. So 7x is equal to negative 5. Then we're going to divide by 7. And x is equal to negative 5 over 7. All right, so let's look at another example. We have 2x plus 9 is equal to 5x minus 3. Okay, so we can do this two ways. There's the option 1 way and the option 2 way. Okay, and these are going to be different for this equation. Because if we do option 1, we're going to get rid of the smaller coefficient side, which is this side, the left side, the 2x. But if we do option 2, we're going to get rid of the right side, which is the 5x. So I'm going to show you both ways. I'm going to show you how you end up with the same answer either way. So for option 1, 2x plus 9 equals 5x minus 3. So remember, this is where we get rid of the smaller coefficient, which is the 2x, so minus 2x from both sides. So we get 9 is equal to 3x minus 3. Now we solve our two-step equation. So we add 3 to both sides. And then last step would be divide both sides by 3. So our answer is x equals 4. Now if we were to do option 2, we would just get rid of any variable on the right side. So we would have to get rid of this 5x, eliminate the 5x. So in order to eliminate the 5x, we're going to subtract 5x from both sides. So 2x minus 5x gives us negative 3x. Okay, then we solve our two-step equation. Subtract 9 from both sides. 3 minus 9 is negative 6. And then we divide both sides by negative 3, and x equals 2. And so I realized that we have two different answers from option 1 and option 2. So now we need to go back and make sure that our math is correct. So let's go back to option 1. Let's see, we subtracted 2x from both sides, and then we added 3, and then we divided by 3. Okay, so everything looks good here. Option 2, let's check our math. We subtracted 5x. Okay. Oh, here's something that we didn't do. This was 5x minus 3. So this should be minus 3 here, right? So 5x minus 3 minus 5x leaves us a negative 3, right? And negative 3 minus 12 is actually, sorry, negative 3 minus 9 is actually negative 12, okay? So that means x is equal to 4, because negative 12 divided by negative 3 equals 4, okay? So it shows you that whether you do option 1 or option 2, you should get the same answer. If you don't, go back and check your work. All right, so let's go look at another example, example 4. Which says this: 7x minus 5 is equal to 3x plus 10. All right, so we're going to eliminate the 3x. So we're going to subtract 3x from both sides. So 4x minus 5 is equal to 10. Now we go ahead and solve our two-step equation that we created for ourselves. So we add 5 to both sides. And then we divide by 4. And this is the part where this fraction, an improper fraction here, is okay to leave as your answer. If it reduces, you're going to want to reduce this, but 15 over 4 does not reduce. So you can leave it just like that as an improper fraction. All right. Next example, we've got 4x times x minus 3 equals negative 2 times 3x plus 11. So this is a little bit more complicated because not only do we have variables on both sides, but we have these parentheses. Remember, we talked about how to take care of those parentheses. We use the distributive property, right? So 4 times x leaves us 4x. 4 times negative 3 is negative 12. Negative 2 times 3x is negative 6x. Negative 2 plus 11, negative 2 times 11 is negative 22. All right, I'm going to choose the option of taking out the smaller coefficient, which is negative 6x. So to get rid of a negative 6x, to eliminate a negative 6x, I'm going to add 6x, leaving me 10x minus 12 equals negative 22. Now I'm going to solve my two-step equation. Add 12 to both sides. Negative 22 plus 12 leaves us negative 10. And my last and final step would be to divide by 10. So x would be negative 10 divided by 10 is negative 1. All right, one last final example before we go. Example 6. Which says this: negative 3 times x plus 4 is equal, negative 3 times x plus 4 minus 8 equals 3x plus 4. So again, we have to eliminate our parentheses first by using the distributive property. So negative 3 times x is negative 3x. Negative 3 times 4 is negative 12. Then we have our minus 8 equals 3x plus 4. We've got to combine like terms. So negative 12 minus 8 is negative 20. Now we're going to take care of our variables, right? So there are two different ways you can think about doing this. You can eliminate the 3x, or you can eliminate the negative 3x. So option 1 would be to eliminate the smaller side. Option 2 would be eliminate what's on the right side. So either option will give you the correct thing. I always like to eliminate the smaller coefficient. I always like doing that because it usually takes care of my negative. So I'm going to eliminate the minus 3x by adding 3x. So negative 3x plus 3x equals 0, leaving negative 20 equals 6x plus 4. Solving my two-step equation, subtract 4 from both sides. Last step, divide by 6. And x is equal to negative 4. All right, so your homework on page 321, which is 8.2, you're going to do 2 through 6 evens. They are due in class whenever you turn your notes in. Okay, 2 through 6 evens due in class with your notes. Thank you for watching.